image 4, right? So if we did say image 4, your thumbnail shouldn't exceed 400 pixels horizontally, 200 pixels vertically, right? But what is image 4's size? You see that the 200 is reached, right? It's being touched. However, due to the preservation of the aspect ratio, thumbnail did not sort of horizontally stretch the pixels to become very distorted version of the original picture. Instead, it sort of didn't fulfill the 400 that we gave. And instead, it just takes up 266 pixel. So unlike resize, so the resized picture looks a bit distorted, right? But if we look at image 3's size, it will be exactly what we have instructed. It will be 400, 200. So when you think about thumbnail, think about this 400, 200 not as in the way as resize width and height, but rather as a maximum bounding box, which is kind of neat because that's exactly how we would like thumbnails to be shown in our blog, in our website, because you want the aspect ratio to be preserved. Imagine going to a web page where you see the pictures being distorted, right? It will look funny. It will give people different impression, nothing positive. And so thumbnail should keep the aspect ratio. Okay, next up, we want to talk about, what do we want to talk about? We want to talk about splitting, right? Where's my splitting? Okay. Oh, all right. I store it in another part of the file. All right. Okay, next up is our split merge demonstration. So first, let's comment out the shows so that it won't start popping up and covering up our screens again. So what we want to do is to use image 1, which is our source image, and split it into R, G, and B. All right, so it's going to give a tuple, but not integers, but a tuple of image objects. So they're going to look a little bit eerie in terms of having red only kind of shades, green only and blue only of the original image. Then we can print out what is the mode of the splitted images, all right? And then we will merge. Merge is the reverse of split. Give it a tuple of 3 images in terms of, or interpreted as red, green, and blue intensities. It will combine them into, colorful form, all right? Although we may not appreciate the resulting ghostly looking kind of images. So let's have a look first in terms of what is image A, B, and C. That's the original image. The combined, or merged images. So when we printed the mode of R, G, and B, or from the splitted images, you notice that the mode is not RGB, but L. L simply means each pixel has got only one integer ranging from 0 to 255. Let me say again. So in this here, all right, so any of these, the R, the G, and the B picture, they are pixels again of the same size as the source. Did I get it right? Oh, image LR, right? Yeah, dot size, right? So image LR, it's the same size as image 1. Yeah, but image LR, the mode is L, meaning it's only luminance. Luminance simply means each pixel is one integer from 0 to 255, indicating the intensity. Intensity of what color? But we already know this is the red color. So if we show LR, we can, but it's not going to be red color. It's gray color because it's got only 0 to 255. And it's supposed to be interpreted as the intensity for red color. Yeah, but we abuse it. We kind of like force merge function to take the red color as green color. That's why we position it here, right? And then see the results. And of course, the results, we have seen it before. It's going to look a little bit off But sometimes that's an artistic effect that we want to generate. Sometimes it is called the false color that we want to produce to enhance certain weaker colors. Like green may not be so catchy on the eye, so we might want to turn greens into blues to make it more visible, make it more catchy, and therefore allow us to visualize the data or that aspect of the data better. So again, there are different uses of these um, splitted channels, right? So we can split them up. All right, it's almost like a lens where the white light is being decomposed. Then we can adjust each of the rainbow colors. Well, in this case, not rainbow, but three channels, right? We can adjust them separately and then recombine them using merge. So let's try just based on interactive commands. If merge is the opposite of split, then what happens if we just do an image merge of RGB and we supply a tuple with exactly the original red, original green, original blue. That's little L here, not one. Okay, so once we do this, we will get a combined image, and what do you expect? It should look exactly like the original. See, we get back the brilliant colors. Okay, so definitely it's a very faithful copy of each of the channels, and that gives us new insight into what is very plain and visual. It's almost as if we get not X-ray, but sound seems like X-ray, right? We get to see the invisibles. What happens if we only see the red? Oh well, that will be the thing, right? So that is going to basically allow us to adjust individual images. Okay, that's good. Uh, and what we want to do now is to do a bunch of image enhancements. Okay, so how do we do that? Okay, image enhancements. Code is coming up right here. Okay, so first thing first, remember is that we need to import the enhancement module, submodule. So again, remember, as we discussed in the classroom, enhancement is just to make things more acceptable, natural, enjoyable, more brilliant for human consumption. So if you're looking for mathematical calculations, vision, computer vision processing, you might not want to use this library, but consider using image filtering libraries. So here we will uncomment the previous show so we don't get too many images popping up. Next, we want to just follow the slides by copying all the enhancements. So first we try to put a notch up the color to make it more brilliant, all right, make the colors more brilliant. Then we can show it. And then we create another image, image 3, that's going to enhance the contrast. Notice how we call the functions provided by image enhance. We link, right, the source image via the contrast command to create a sort of a object that is ready to perform enhancements. The reason why we do this is sometimes we want to test run. Let's try enhancing by 1.8. No, that's too strong. How about 1.5? Oh, that's too weak. And then we increase 1.6, So when we have a properly semi-calculated object there, then having all these final numbers being provided in this final function call will make the enhancement run a bit faster. So that's the point of having this indirect call. Okay, so then we try to show that contrast. We can brighten up by a factor of 2. Now, this is by no means meaning that all pixels are multiplied by 2. That's not really the case. It's just sort of a tuning parameter. The larger it is, the brighter it is. Okay, and you can give it like 500 even, but it will be a sea of white, and you may not necessarily want to do that. Okay, and we can sharpen the image by 3 times. Again, that doesn't mean we do any multiplication, but just means more. sharper. Give me a sharper image. Okay, so we show all these. Okay, original image, color enhanced, really nice. This looks like contrast, brightened, and sharpened. The sharpened image here might force certain edges to be very artificial looking, right? So in this case, picture has got a bit of blurry there, and when you sharpen a blurry image, you're gonna get like dual vision. So it's not always a good thing to sharpen every single picture that you see. This brightened picture is obviously compared to other or other versions of the same image, really brightened, right? So and again, black is still black, right? It's a brightened black, but now we can see, oh, the the sort of black shirt that this guy is wearing is not the same black as the trousers. The trousers is truly very black, and the shirt is actually a bit darkish but gray at the same time. And when you brighten it up, whoa, things start to look slightly different. Yeah, and of course, many parts like the mangoes here and the apples there, they are overexposed. You can't tell a thing. It's a sea of white. Yeah, but then this helps a lot in darkened corners of the the picture. So with this high contrast picture, you can see that high contrast can also mean a little bit of enhancements in the color, but it's not the main thing. It also implies a little bit of brightening, but again, it's not directly the same thing compared to brightness. So contrast makes it easier to see things on the eyes. All right, so sharp contrast means it's quite detectable that there are distinct objects and features in the picture. That's the meaning of contrast. So if you go to your television, you will see, the familiar brightness control, contrast controls, and all these are basically uh very visual aspects that will please the eyes rather than to perform mathematical calculations. Um, Over here, this is a color enhanced image to make all the colors richer. So if you have a fruity color picture like this, where a lot of colors appear, right? Or perhaps it's fireworks, perhaps it's neon lights or whatnot, then having color enhancements really make the picture very brilliant. Yeah, and in this case, perhaps a tad bit too brilliant. The orange here starts to look a bit artificial, right? But the mango looks really, really delicious. As compared to the original picture, you probably want to buy this yellow looking mangoes than this pale or looking rotten kind of mangoes, right? But if your eyes are only tuned to this original image, then, well, the mangoes look fresh again. So it's very much a subjective assessment. Now, that's for image enhancements. Image enhancements. Next up, we want to run a bit of filter. Now, filter is going to be a little bit more a serious show, and outcomes are not always very pleasing because it's meant for different purpose. It's meant for special search for certain things that are hidden somewhere in the pixels. So for example, we talked about contours, edges, so these are the filters. To do filter, you need to import a new submodule, right? As we learned, we need the image filter modules. The image filter module actually provides a kernel, we'll see in a while, but there are predefined, commonly used filters. For example, we want to do contour, emboss, and find edges. Let's just see them first.